Okay, 3.2 is on trigonometric integrals. Okay. For the integral sine to the nth power of x, cosine to the nth power of x dx, if we have sines and cosines, powers of sines and cosines in at play in our integration, okay, we're going to tackle these using some rules here. Okay, first, if the power of cosine is odd, save one cosine factor and use 1 minus sine squared x for the remaining cosines. Okay, so we factor out a cosine and then change all remaining cosines to 1 minus sine squared using to sines using 1 minus sine squared x. Okay, that's if the cosine is odd. We pull out a cosine and then everything else goes to 1 minus sine squared x and whatever powers of that we have. Okay, and the reason that we want a cosine to get factored out is because that's going to end up being our du. Okay, which will make it a nice u/du substitution. Because everything will be in terms of sines, and then I'll have a cosine as my du, as my integration factor. Okay, if the power of sine is odd, then do the same thing, but in reverse. Save one sine factor and use 1 minus cosine squared x for the remaining sines. Okay, number 3. If the power of sine and cosine are both odd, then you have a choice of 1 or 2. Okay. Number 4. If the power of sine and cosine are both even, use half angle identities. Okay. Sine squared x equals 1/2 minus 1/2 cosine 2x. Cosine squared x equals 1/2 minus or plus 1/2 cosine 2x, and sine 2x is equal to 2 sine x cosine x. Okay, so we have these identities there. Okay, let's try a problem here. Number 1. Okay, evaluate the integral of cosine cubed x dx. So here cosine is odd. So we're going to want to factor out a cosine and then change everything else to sines. So this is going to become cosine squared x times cosine x dx. Then we're going to use the Pythagorean identity of 1 minus sine squared x times cosine x dx. I can now distribute the cosine, and I get the integral of cosine x minus sine squared x cosine x dx. I could break this up into 2 separate integrals now. Integrate cosine x dx minus the integral of sine squared x cosine x dx. So now this is just a u substitution on the second integral here. Okay, the first integral will just go to sine. That's really nice. That's sine x. The second integral I'm going to do a u sub on. So u is equal to sine x, du is equal to cosine x dx. So this thing becomes the integral of u squared du. The integral of u squared is just u cubed over 3 plus c. Okay, there's no limits of integration, so I can't evaluate. But I do want to plug in what u was. Well, u was sine x. So this becomes sine x, which was brought down from my first integral, plus 1/3 sine cubed x plus c. Okay, and that was the integral of cosine cubed x dx. Right? Okay, number 2.
Didn't
Fine.
it be minus?
Did I mean minus?
Yeah. It says
Yeah, it is minus. Thank you. How did I mess up? Oh, that is minus. Thank you. Thank you. Thank you. Minus, yes. Okay. Yeah, the minus. I forgot to bring the minus sign in. Thank you very much. Good catch. Okay, number 2, find the integral of sine to the 5th x times cosine squared x dx. Okay, so this is going to be the integral. I'm going to, because sine is odd, I'm going to pull out a sine. So this is sine to the 4th x times cosine squared x times sine x dx. And I'm going to change my remaining sines to cosines. This is 1 minus, well, let me write it like this. This is sine squared x squared times cosine squared x times sine x dx. This becomes 1 minus cosine squared x squared times cosine squared x times sine x dx. We're going to multiply this guy times himself. So that when I FOIL that out, I get 1 minus 2 cosine squared x plus cosine to the 4th x times cosine squared x times sine x dx. Now I'm going to distribute the cosine squared. So I get cosine squared x minus 2 cosine to the 4th x plus cosine to the 6th x all of that is now times sine x dx. So now I want to do my u sub. My u is going to be cosine x. My du is negative sine x dx. The derivative of cosine is negative sine. So I get a negative du is equal to sine x dx. I'm going to pull this negative sign all the way out in front so I don't forget about it. When I do my u sub here, I'm going to say, oh, this is a negative, pull it all the way out in front so that I don't forget it. This becomes cosine squared, which is u squared, minus 2 u to the 4th plus u to the 6th du. Now I'm going to do some simple integration. This is going to become negative of u to the 3rd over 3 minus 2 u to the 5th over 5 plus u to the 7th over 7 plus c. I could distribute my negative sign. This is negative 1/3 u to the 3rd plus 2/5 u to the 5th plus 1/7 u to the 7th plus c. Sorry, that's a minus. I start going too fast and I mess up on the pluses and minuses. Okay, now I just need to plug in, well, what was u? Negative, it was cosine x, right? Okay, cosine cubed x plus 2/5 cosine to the 5th x minus 1/7 cosine to the 7th x, or cosine x to the 7th plus c.
Uh, just for clarification, could you scroll up just a little?
Yeah, sure.
Thank you. You chose U because it was the one that was grouped with everything else. Like there was multiple cosine x's, right?
Right. So so I'm gonna replace that and do a du. So that's the reason that I wanted to break off the sine x, was because I knew that cosine was going to end up being my u. I would end up with multiple powers of cosine. And so when I do the u for cosine, I end up with a sine for du.
Oh, and that comes from the sign being the odd power. That's why you change it in the first place.
Exactly.
Okay, thank you.
Perfect. Okay, we ready to move on to the next one? Anybody still need more time on this? Okay. Let's move on to the next one. Okay, this one we're going to have limits of integration. Okay, so 3. We're going to go from 0 to pi of sine squared x dx. Okay. So we could use a power reducing formula that we derived in our last section, but let's just do this one by practicing our half angle identities. Okay, so this I can turn from a power into something linear by using the half angle identity. The power of sine here is even, and so we could turn this into 1/2 minus 1/2 cosine 2x dx from 0 to pi. Okay, I'm gonna have to do a u sub on this. Okay, so I'm gonna actually I'm gonna factor out the 1/2. I'm gonna pull the 1/2 all the way out in front. 1/2 times 0 to pi of 1 minus cosine 2x dx. Okay, I want to let u equal 2x. So therefore, du is equal to 2 dx. Okay, divide by 2. So we get 1/2. Okay, my new limits of integration, u of 0 is going to be 2 times 0, which is 0. U times pi is going to be 2 pi. So this will now go from 0 to 2 pi. Okay, of 1 minus. Okay, this is going to be cosine of u times du over 2. Okay, so when I integrate this, this is just going to become u. The integral of cosine is sine, so this is minus sine of u from 0 to 2 pi. I'm going to multiply the 1/2 times this 2 1/2. So that becomes 1/4 on the outside. I'm going to pull that all the way out. That 2 on the bottom, I don't want to forget about this guy. And combine this guy with this guy, so that's 1/4. Okay, and so now I'm just going to plug in for my limits. So I'm going to go 1/4 times 2 pi minus the sine of 2 pi. Okay, times or minus 0 minus the sine of 0. Okay, everybody knows that the sine of 2 pi is 0, for all you guys that are trig wizards. Everybody knows that the sine of 0 is also 0. So everything goes to 0 except for the 2 pi. The 2 pi is the only thing to survive. So I'm left with 2 pi times 1/4, which is 2 pi over 4, which becomes pi over 2. Number 3.
Professor, I had a quick question.
Yeah.
How come you didn't turn the u back into the 2x?
Because I had already changed my limits of integration.
Okay, I see.
If I didn't change my limits of integration, I would have had to replace the u with 2x.
I see. So that's only for indefinite integrals.
Correct.
Got it.
Okay, let's look at the rules for tangent and secant. For the integral of tangent of m to the x, okay, secant of n to the x dx, for an integral of this form, okay, our first rule is if secant is even, factor out a secant squared x. And convert remaining secants to tangents using secant squared x equals tangent squared x plus 1. Because what's the derivative of tangent?
Secant squared.
Exactly. Thank you, Corey. The derivative of tangent is secant squared. So we pull out that secant squared to get our u du integration factor. Okay. So remember, d dx of tangent is equal to secant squared x. Okay. Number 2, if tangent is odd, factor out a secant x tangent x and convert remaining tangents to secants using tangent squared x equals secant squared x minus 1. Because what's the derivative of secant?
It's secant tangent.
Exactly. This is just kind of a little aside. Okay, so again, we're using derivatives to kind of like help us integrate. Okay, the properties of derivatives are going to help us integrate. Okay, and number 3, if all else fails, pray. No, I'm just kidding. Okay, number 3, we have another method for using derivatives to help us get integrals. What did we call that? What was the last section called?
Integration by parts.
Exactly, integration by parts. When all else fails, use integration by parts. Okay. Number 4. Okay. Number 4. I want to set this up, okay, so that we understand what is the integral of tangent x dx. Okay, this one's actually, we don't have to use any of the rules for this. This is just straight u sub. Okay, but we should have a working understanding of what the integral of tangent x is. Okay, at this stage in the game. So let's first figure out what is tangent x. What's the integral of tangent x? So just one tangent x. And in order to do this simply, we're going to change this to sines and cosines. This is sine x over cosine x dx. And this is just a straight u substitution. Okay, so u is equal to cosine x du is equal to negative sine x dx. So negative du is equal to sine x dx. Okay. So the integral of this guy, we have our du as sine x dx, and we have a negative 1 over u. Right? So that becomes negative natural log of u plus c, when I integrate, this becomes the natural log, okay, of u to the -1 power, okay? I'm gonna put the absolute value bar still there. Okay, so this becomes the natural log of the absolute value of 1 over u plus c. Okay, but what was u? U was cosine, right? So this is the natural log of 1 over cosine x plus c, which is the natural log of what's 1 over cosine x?
Secant.
Secant x. Okay, so the natural log of secant x plus c. So what did we find? We found that the integral of tangent x was equal to the natural log of secant x plus c. Okay, that is that's an identity. Okay, that's something that you could memorize. Okay, this is an identity. Okay, so what was the derivative of tangent? The derivative of tangent was
Secant squared x.
secant squared x, exactly. What's the integral of tangent? Natural log of secant x plus c. Okay? So now we know how to take the derivative of tangent and the integral of tangent. Okay, one other thing that I want to, well, let's get into some of these evaluations. We'll come back to the integral of secant. We'll do the integral of secant last, of 1 secant, because it involves a trick. Okay, but let's go on to number 5 here, where we just want to evaluate some tangents and secants. Okay, evaluate the integral of tangent to the 6th power of x secant to the 4th power of x dx. So both of these are even. So what are we going to do?
Factor a secant squared x.
Yes, exactly. Use number 1 from our notes. Factor out a secant squared x. So this is tangent 6x secant squared x dx. And then we want to change this secant into a tangent. So secant squared x is tangent squared x plus 1. Right? And so I'm going to distribute. This becomes tangent to the 8th, sorry, tangent x to the 8th. I'm gonna stop saying the x because it just gets confusing. This is tangent to the 8th power plus tangent to the 6th power times secant squared dx. Integrate. Now we're going to want to do our u sub. U is equal to tangent. Du equals secant squared x dx. So this becomes the integral of u to the 8th plus u to the 6th du. Very simple. This becomes 1/9 u to the 9th plus 1/7 u to the 7th plus c. But what was u? It was tangent. That's it. Easy. Let's do another one. This is number 6, I believe. Okay, find the integral of tangent to the 5th power of theta secant to the 7th power of secant to the 7th power, secant theta to the 7th power, d theta. Okay, here we have both are odd, so what are we going to do here? Both have an odd power.
Factor secant x and tangent x.
Yes, factor out a secant x and a tangent x. We get secant x or secant theta, tangent theta, d theta. Who was that, Daniel?
Yes, Professor.
Sounds good, thank you.
Ah. Thank you.
Okay, so this becomes tangent to the 4th theta, secant to the 6th theta, times the secant tangent. Well, the derivative of what is secant tangent? The derivative of what is secant tangent?
Secant.
Yeah, secant. So we want to turn everything into secants, right? Okay, so I want to change this guy into secants. So I'm going to make him secant squared theta squared times secant 6 theta okay, all of that times secant theta tangent theta d theta. Now, what is secant squared? Sorry, I'm sorry, this is tangent squared. I messed up. Okay, that should be a tangent squared theta. But what is tangent squared?
It's secant squared x minus 1.
Yeah, secant squared theta minus 1 squared times secant to the 6th theta times secant theta tangent theta d theta. So u, well, let's distribute. Let's multiply this out first and distribute. So this is when I FOIL this out, I'm going to get secant to the 4th minus 2 secant squareds plus 1 times secant to the 6th theta times secant theta tangent theta d theta. We're still integrating this thing. So now we're going to distribute this secant to the 6th. This becomes secant to the 10th minus 2 secant to the 8th plus secant to the 6th secant theta tangent theta d theta. Okay. So I'm going to do a u sub on this. U is going to equal secant theta. Du equals secant theta tangent theta d theta. So this becomes the integral of u to the 10th minus 2u to the 8th plus u to the 6th du. So this becomes 1/11th u to the 11th minus 2/9 u to the 9th plus 1/7 u to the 7th plus c. And now let's just plug in what u was. That's 1/11th secant to the 11th minus 2/9 secant to the 9th plus 1/7 secant to the 7th plus c. So, let's do one last one. Okay, this will be the last problem that we do for the evening. Okay, and that's gonna be this guy here, the integral of secant x dx. Now, I don't know how some genius came up with how to do integral secant x dx. I mean, it's just playing around with trig and being an expert at trigonometry, I guess. But there's a special substitution to do this. Okay, there's a special kind of an integration buddy, if you want to call it that. And how they came up with this integration buddy, I have no idea. Someone smarter than me. Okay, so if we do secant x, and then we multiply this guy by secant x plus tangent x over secant x plus tangent x, we'll call this my integration buddy. Dx, then a lot of really nice things happen really quickly. Okay, this becomes, if I distribute the secant, you can see what happens is I get secant squared x plus secant x tangent x on the top. It's like a miracle occurs. And then I get secant x plus tangent x on the bottom. Well, what's amazing about this is the fact that the derivative of the bottom is the top. And so if I let u equal secant x plus tangent x, then du is actually the numerator after using my integration buddy here, which is just, it's a miracle. Okay, the center holds in the universe. Okay, so du is equal to secant squared x plus, or sorry, secant x tangent x. Du is equal to secant x tangent x plus secant squared x dx. And that's exactly what I have on the top. So this just becomes the integral of 1 over u du, which is what?
ln u.
Yeah, that's just the ln of the absolute value of u plus c. And so this becomes the natural log of u, which was secant x plus tangent x plus c, and that is the integral of secant. Just amazing. It's mind-boggling. Okay. And so we now have identities. This is another identity. We now have identities for the integral of let's do this. The derivative of tangent is secant squared x. The integral of tangent is the natural log of secant x plus c. The derivative of secant x is secant x tangent x, and the integral of secant x is equal to the natural log of secant x plus tangent x plus c. Again, really beautiful formulas here. Okay, so these are all identities. We can take the derivative of tangent, we can take the derivative of secant, we can take the integral of tangent, and we can take the integral of secant. Okay, and this is on this form, which I think I've shared it before. Right? Like, where's my calculus. I don't know why it's not doing. Oh, Curio, calculus formula sheet. Let me share this with you. Sure. Oops. Everyone in the meeting. Let's try that. Whoops, let's try that again. Stop. Okay. You will be allowed to use this on the next exam. So I think I've shared it with you already, but
Yeah, you have.
okay. Okay,
Yeah,
sounds
it's in the files on Canvas.
okay, perfect. Okay. Okay, sounds good. Okay, just in case it is there. Okay, and that is section 3.2.